Technology or DOST TAPI. I would like to thank our finalists for being here today, and of course, congratulations po at the same time for leveling up. Iba na po ito kasi final round na ito of the contest. So again, congratulations. You are therefore concluded as winners now already. Kasi iba na po yung pinaglabanan natin, region-wide, region 6, 7, and 8 na po siya. So we would also like to thank our DOST Region 7 for the technical and administrative support, and to our DOST regional coordinators from Regions 7 and 8 for the support in reaching out to our students with their advisors and researchers to participate in the cluster rise. Of course, we would also like to thank Apo ng Abala, the DOST TAPI Program Manager of the Institutional Support for Trade and Exposition, Ms. Rodelia R. Padilla. And we would also like to acknowledge the presence of the Division Chief of the Investment and Business Operations Division of DOST TAPI, Mr. Romeo R. Habate. Okay, and later on we will be joined by the Division Chief of the Invention Development Division, Mr. Taizar Angelito E.R. Sayo. Of course, good morning also to my DOST TAPI colleagues who will be supporting us today and tomorrow.
Outstanding Creative Research or CPOL Award po, no? So the Student Creative Research refers to new and innovative projects or models developed by students. So these projects or models possess features that may have significant contributions to the promotion of science and technology innovations. So this is subcategorized into college and high school. This morning, we have witnessed the high school level, at ngayon namang hapon, we will witness the college level. So to start off, we will have the entry project FERRO-FLIGHT, FERROUS Nonahydrate Nanoparticle as a cost-effective reduction-oxidation catalyst for UAV quadcopter hydrogen fuel cell applications. Yan, tama po ba yung pagkakabasa ko? And the team leader is Jose Virgilio Calambuhay Jr. from Philippine State College of Aeronautics, Mactan Campus.
Good afternoon, ladies and gentlemen. Good afternoon, esteemed Board of Judges. I'm so happy and I am so honored to be here to be presenting to you, representing the Philippine State College of Aeronautics at Mactan Campus. My research is Project FERRO-FLIGHT, which is an innovation of ferrous monohydrate nanoparticle as a cost-effective reduction-oxidation catalyst for UAV quadcopter hydrogen fuel cell applications. So, the Project FERRO-FLIGHT has a lot of novelty and commercial advantage because, as you have known, fuel cell technology nowadays is very expensive, and as you can see, $39,000 must be spent for a single fuel cell stack. However, Project FERRO-FLIGHT is here with its unique ferrous-based technology offering, number one, cost effectivity. Because ferrous and copper nitrate are very much available and very accessible, they are also very affordable. Second, extensive applications. Project FERRO-FLIGHT is basically a source of electricity for a lot of electrical applications. You can use it to fuel quadcopter drones, to fuel cars, and any other electrical appliances that needs in-demand electricity. So we are trying to compete not just with platinum-ruthenium fuel cell technologies that are currently available today, but we are also competing with lithium batteries that needs to be mined and is very environmentally unsustainable. So, because of its extensive applications, Project FERRO-FLIGHT, unlike lithium-ion batteries that you need to recharge, you can just refuel your tank in just literal seconds and have a full-blown prototype working again without the need to wait for charging times. The third is viable manufacturing costs. Because of the lack of platinum-ruthenium catalyst that is needed for creating the fuel cell, the manufacturing cost of the catalyst for Project FERRO-FLIGHT is greatly reduced. Thus, it is more viable for companies to open a factory here in the Philippines, and also it encourages a lot of job applications for Filipino workers. Number 4 is reduced environmental impact. So this hexachloroplatinic acid, which is the most commonly used fuel cell for today's fuel cell technologies, they need to be mined, and because we know that platinum in itself and ruthenium is a noble element, that means it is rare to find. So we need to mine and displace a lot of land mass in order to gather sufficient amount of platinum and ruthenium just to create these catalysts, which makes them very unaffordable and inaccessible to the layman like ours who cannot afford these such huge numbers of grams per price per gram. So as you can see here, Sigma Aldrich, Fisher Scientific, Westlab, and ChemSupply, you can purchase per gram of the ferric nitrate monohydrate crystal at less than $1, whereas the hexachloroplatinic acid requires $340 per gram, and that is already a discounted price for researchers like me. Next, here are the methodology and test results. So, Project FERRO-FLIGHT is a pure experimental, post-control group-only research design, and the experiments are conducted at the Chemistry Laboratory Facility of Philippine State College of Aeronautics, and a flight test will be conducted at Danao City, Cebu on or before December 2023. I would like to open to everyone that my research has been conducted since September 20, 2023. It has been just a month, and we have already achieved outstanding results. So as you can see, the control, the platinum ruthenium, has a current density of 1.8, whereas our best bet, which is the ferric and the copper nitrate monohydrate catalyst, has a 0.67 current density. The control, which is 0.6 in voltage density, while our iron plus copper has a 0.47 voltage density. And the power density is 2 kilowatts per kilogram, where ours has 1.5 kilowatts per kilograms rather. So we boast that the fuel cell that we made has a 61% fuel efficiency compared to the control PTRU catalyst, but at 98% less the cost from the initial price. So it really is an outstanding innovation because we are trying to build a fuel cell that is available to the masses, that the community can afford, so that a lot of people will be maingganyo sila na mag-transition from fuels from fossil fuels or even lithium batteries towards a hydrogen technology. So here I'd like to show you a video.
Time's up, sir.
Okay, thank you, Jose. May we now hear the questions from our judges. Let's start with Ms. Brian.
Congratulations and thank you sa presentation. So, based on your test results, parang sinasabi na it's more cost-effective than platinum-based catalyst. My question is about the compatibility of the FERROUS NONAHYDRATE nanoparticles with the other fuel cell components like the membranes, yung electrolytes. How compatible do you think it would be?
So, in terms of compatibility, we have actually a very different electrolyte used for this specific for this catalyst. From the making of the ionic liquid, we choose a different ionic liquid. We also have a different method of electroplating the cathodes, and still, though the only same thing is the gas diffusion layer, and also the perfluorosulfonic acid membrane in between is the only thing that it is compatible, but the others were really revised from scratch, and it yielded some great results as far, so I could say that it is compatible with the current design that we had. And also, I would like to, as I wasn't able to finish my presentation, I would like to clarify that the caveat for having a cost-effective catalyst is that it has a shorter lifespan compared to the platinum ruthenium catalyst because the ferrous nonahydrate is prone to corrosive attack, and as nature of the iron, it is really prone to corrosive attack, and that's what we are trying to research on, to really develop a catalyst that can survive the corrosive attack when it is under operation and expand its lifespan without affecting the results. So as you can see, it is cheaper, it has a lesser lifespan, but on the other hand, it also is more accessible to the public. So that's what we are really trying to prioritize on, to create a fuel cell that is affordable for the masses so that they can transition as early as now towards renewable energy. While among is sacrificed, we will sacrifice the lifespan of it. But rest assured that we are going to keep on experimenting and finding more, because at this moment, the method that we do to increase the lifespan of the ferrous nonahydrate is we electroplated it with a graphite, because graphite is very, graphite is stable, so it is not prone to corrosion. Now, through electroplating of the catalyst, it becomes more stable as well, but we are also trying to find out more ways and more tests to conduct to see for how long is it going to maintain that 66% efficiency that we showed before. So as I have said, we are still 1 month in the making of this research, but we have already shown you great results, and if you would give us the chance, we would like to present it to you right now, if it's okay. So we didn't bring a full fuel stack at this moment because a full fuel stack for a drone would require a gas tank to operate, which is quite dangerous. So what we're going to do is to synthesize hydrogen gas by using aluminum foil and muriatic acid, and then we are going to put the sample fuel cell that we have made and check if it is producing any electricity as an output.
Okay.
Yes.
So the only thing that makes thank you, ma'am. So the only things that makes fuel cells very good for conducting electricity is that because it uses hydrogen gas for its cathode catalyst, the electrons goes from the anode to the cathode, and then it reacts with the hydrogen ions, and then with the oxygen in the atmosphere, it actually converts those hydrogen into water vapor. So the only byproduct of our fuel cells is just water vapor and no other any greenhouse gas that is emitted. So, last but not the least, this is the sample of the hydrogen the ferrous catalyst without the copper plating that we've made. So the perfluorosulfonic acid that we use is a NAF-ion 3015, which is 15 micrometers thick, and it allows for the passage of protons within it, and it strips off the electrons from the hydrogen gas. So the stripped off electron runs towards the anode, towards the anode, and then goes to the load, whatever it is the load, and some appliance that you're going to use it for, and then goes back to the cathode and reacts with the oxygen in the atmosphere and becomes a water vapor. So this is the sample of the fuel cell. And so in our path towards a greener and a more prosperous Philippines, this study really aims to make the fuel cell and other renewable technologies more affordable to the public. So we wanted to help the Filipino community transition towards more hydrogen consumption and empower the researchers to do similar fields of this study in renewable technology. So it is not just an idea, it is also a vision of a cleaner and brighter Philippines.
Thank you so much ka. Ilang pala pang aeronautics yung as inventor. I think kailangan niya ng mga tao ng civil aviation and authority of the Philippines. By the way, my question is pertaining to technical engineering. We value the engineering economy as well as the value engineering. No? We always make a comparative analysis in such a way we as engineers make our engineering report with that design, installation, operation, and maintenance. So this will be part of your questions. Kindly provide your report a comparative or comparison analysis since you are using the unmanned aerial vehicle or commonly used known as drone. No? Okay. Your UEV quadcopter using an alternative source of hydrogen fuel cell application against the commercial application that they are using now, such as the battery operated, for charging, and even the bigger drones that they are using, highly fuel, maybe very mataas na talaga na yes, for fuel. Such as for the airplanes, so that you can make an adjustment for that one. This is our research, and this is the commercial application. It will give the value for that one. Then comparative analysis that this hydrogen fuel cell application is very reasonable and alternative source in the Philippines that we are going to use in the future. And lastly, based on your report that on December 2023 we're going to conduct a test, kindly record for that one because next year, as one of the clusterized finals will resort, then you have the actual test regarding your report and research. Thank you.
Alright, thank you very much, Jose, for your presentation with a demo. Okay, so next up, we have the